Hi everyone, I'm Serafim, I work for Debian. I'll be talking about how to replace a legacy maintainer tool with a large number of reverse dependencies. Just a show of hands, how many people here know what a maintainer script is? Okay, so I'll just spend a few seconds explaining. When you install a package, or when you uninstall a package, some packages can include in them a so-called maintainer script. So when you install the package installer is actually running that maintainer script. So I'm talking about a tool which is used by about 50 maintainer scripts. And it's a legacy tool, so it's something that we'd like to replace. And the challenge is getting to coordinate with the 50 package maintainers to do that. So the audience of the talk is basically maintainers of community distributions, and by that I mean distributions where there is no benevolent dictator that says, we will do that. It's about distributions where you have to convince people, you have to get consensus to do something. And the tool I'm talking about, the case study is Debian specific, but I'm drawing some lessons which are, I think, of general interest. So this is not a talk about describing the replacement, it's talk about the process of getting consensus for replacing the tool. And I've planned to make it a short talk, so I encourage you to interrupt me anytime with questions, otherwise I'm going to have everyone's. And this is the message I'd like all of you to go away with at the end of the talk. So the idea is that in replacing a tool with a large number of installations and a large number of reverse dependencies, something that helps a lot is having a design document to describe the new tool, and having a written description of the new tool is key for getting to consensus, for convincing the people that we have to update their packages to use the new tool. And since we also have a design document, that's also a very good basis for writing the tests for the new tool. And I think this is something that Joey Hess, one very influential Debian developer, his tools tend to be very well documented, and I think that a big reason for that is that he actually writes the documentation as part of doing the design of tools. So this is the specific example I'm talking about. Update-inetd, it's a Perl script and a module which was written a long time ago. It's, as I said, it's invoked by maintainer scripts that have server packages that can be run via inetd. I don't know how many people here know inetd? Okay, most. So it's basically a server you can configure to invoke other servers. So when you install, for instance, an FTP package, it will have a script that will be run by a D package to call update-inetd, and update-inetd edits the configuration file inetd-conf and restarts inetd. So this is a very old tool. It's becoming increasingly relevant because most people nowadays can run servers in standalone mode, so inetd itself is not that relevant. But it's still very widely installed and used, and it's quite buggy. So in my opinion, and not only mine, it's kind of broken by design, because to edit the configuration file, you can only specify the service name, and that is not sufficient to uniquely identify entries, because you can have more than one implementation of the same service, or you can have IPv4 and IPv6 services. So there is a certain class of bugs that really cannot be fixed in this implementation without really changing the semantics of the way you invoke it. So a few years after it was introduced in Debian, somebody opened the bug, so that's a very old bug, saying you can only add one entry. And why is this interesting? Because these bugs are still open, and this package is still in Debian. And a few years later, a prominent Debian developer sent a proposal for rewriting inetd. And then a lively discussion followed, which didn't seem to hit into any problems. A year later, I got kind of interested again, so I got another proposal, but this time the right way. So the question is, what is the wrong way of making a proposal about introducing a change which impacts many other packages? And this is a difficult question in community distributions, because in distribution with the dictator will say, we do this, and then everyone does it. But in community distribution, somebody needs to come up with a proposal and convince everyone. And this is one of the big problems in Debian, getting into consensus. So the worst way of making a proposal with cross-package impact is to just send an email to the largest mailing list with a half-baked idea. So something you haven't tried out, something you haven't discussed with other people, you just send it to the largest mailing list, and then chances are it's not going to be good because you haven't really thought about it, but the people that are directly impacted will also be upset because they will be like, you haven't consulted with us. So this is how I've done it more or less the first time. Not as bad as, I've discussed it with a few people, but not enough. And so what is the right way of doing it? Well, this is what I think in my experience up to now. So, draft a design document, thinking about a problem in abstract, it's very easy to think that you figured out all the details, but the moment you're actually forced to put down a written description, you realize of all the issues that were not apparent when you were thinking about it in abstract, as opposed to writing a full detailed description. So once you have the design document, you can bounce the idea of someone that's close to you that will still respect you after having seen you proposing something silly. So once you've passed this basic sanity test, then you can try to validate the main assumptions of the implementation. So do a proof of concept implementation, not a full-scale implementation, just to verify the basic assumptions of the implementation. And it's important not to do a full implementation, because if you do a full implementation, then you will be invested in this idea. You will be too attached to be open to criticism into this idea. So once we know that it works, and it's not a ridiculous idea, then we can actually engage into discussion the people that would be directly impacted by this change. So in the case of update-inetd, that would be the maintainers of the inetd package and the exinetd package. And this is an iterative process, so at every step you tune it, you refine it, you adapt it. And so if they're fine with it, then you can actually send it to the largest mailing list and really start the process officially. And as I said, this is very much an iterative process. Some obvious remarks: people not yelling at you is a good sign. And the last one is not so obvious, but it's tough. So being ignored until you show some code is normal. It's tough because preparing the idea and thinking over it and doing a proof of concept implementation, all these things take time. And you're thinking, I'm doing all this work, people would be appreciative of it. But the thing is that it's so easy to just write an email with ideas and then not follow up. It happens so often that it's normal to be ignored. So until you actually show some code to back the proposals, it's possible that people won't even comment on it. And so, because this process can take a long time, and as I said, the 2001 proposal to replace update-inetd, I couldn't find out what happened from the archives. So mailing list archives alone are not good enough to be able to keep track of the progress of this kind of work. So in Debian recently, some wise people have introduced the Python enhancement proposal process, which is basically very simple. It's just you do the discussion you would do normally in whatever mailing list, but you actually have it's called a dep, it's a document, which is the current state of
it is a driver, so it's the person that drives the proposal, not necessarily the implementation. And it is a status of whether it's still a draft, whether there's been consensus, whether the implementation has been tested and it's actually part of the distribution. So this is useful to have so that if something has been tried before and failed, you don't have to look into the archives. There is a single place in Debian, all the Debian proposals are here, so you can go there and see the things that have been tried before and worked or didn't work, and why. And I don't know whether there are people from other distributions here to say whether there's something similar in their case. I know this is modeled after Python, the Python enhancement process. Okay, no people from other distributions?
well, I'm going to implement that. And well, we are using it inside FOSDEM for our business as well, and we can assign it to managers and stuff like that.
And is there a single place? Yeah, I guess I have to repeat because you're not on the mic. So he's saying that there's something similar in OpenSUSE for keeping track of proposals and the status. Is there a single place where? Yeah.
I'm unfortunately not. I've been through that a couple of times, and there are a number of mailing lists and Mozilla, and it's all over the place. And that's not
So is that Mozilla or SUSE? Okay. So there is a disagreement here.
Yeah, it would be an ideal world, but unfortunately.
So it's not working exactly. Okay.
Well, there are always some people that posting ideas from places.
Yeah. Okay. So this is even in Debian. This is optional. You don't have to do it. But it's not. It doesn't take a lot of time and it's helpful. So.
Well, there are some stuff that we can do without putting it there. We can do stuff directly. And
So it.
the first process is that you should put it there.
Yeah. Okay. Okay. So hopefully by this point we have a proposal. We have consensus. So we can now be confident that we can proceed with the implementation. And if we have a dep or a design document of some sort, then we should have some sort of summary of operation. So a specification of what the tool should do under certain circumstances. This is the summary of cont'd, which is the replacement of update-inetd. I'm not going to describe the specifics of the tool because that's not the subject of the talk. All I want to say is that if you have a design document, it's helpful to have a summary of, given some conditions, how should the program behave. So it's a very simple idea. Yeah, so that is the context in which the program operates, and that is the expectation. So cont'd edits a configuration file, so depending on whether a file exists somewhere, whether the entry is there, and what's the status of the entry, whether there are some other files in other directories, it will remove an entry from the file, it will enable an entry, add an entry, or do nothing. So it's that simple, but having it there, it's very useful for people to look at it and understand what it's about. And now I'm going to do a small parenthesis about behavior-driven testing. So I said in the beginning that a design document is key in getting to consensus. But once we get to consensus and we can start implementation, once we have the design document, we can actually use it as a basis, as an input for system tests. So that's why I will talk about behavior-driven testing. It's only one slide. So behavior, how are we doing with time actually? Okay. Behavior-driven testing, it's a specific case of test-driven testing. So you write the test before you write the code. And in behavior-driven testing, you describe program functionality in terms of features. And every specific use case of a feature is described in a scenario. And every scenario is described in terms of 3 steps, given, when, then. So given a specific set of conditions, a context, when a specific event happens, then this is the expected outcome. And the way it works is that first you describe the functionality, you describe all the features in a sequence of scenario, and every scenario is a sequence of steps. So you start by describing the functionality. And then for every step, you write a method that implements what that step describes. So at this point, we have the human readable description, and the code to which that description is mapped into. We haven't written any code yet, any code that implements the actual program. So when we run this, the tests fail, which is normal. There's nothing there yet. Which is great because we have to see the tests failing first, because it's very easy to write tests that give a false positive, that succeed even though because they test the wrong thing, for instance. So once we see the test failing, then we actually write the minimal code of the implementation to make that test succeed. And once we write the code that makes the test succeed, then we write the next step definition, we write the next part of functionality, and we do this iteratively. I guess I should say that, so the given is the part that sets up the context where the program, in which the program will be tested. So it's like setting up a fixture. And this is, of course, asserting that a certain outcome has occurred. Okay, so now that we are behavior-driven testing wizards, we can go back to our use case, update-inetd. So this is an example of one feature. Remember, in the summary table, we have 4 features. It removes entries, it enables entries, it adds entries, it doesn't do anything. So for each feature, we have a feature file, and the remove feature has 2 scenarios, 1 scenario, we don't know how many. So for every feature, we have 1 feature file. Sorry. And in that feature file, we have 1 scenario. Well, we list all the scenarios. So these are almost identical, but they both have the same outcome. They remove an entry. So we do this for all the features. But it's kind of boring to do this by hand, especially for the no action. So these are just 5 scenarios. We can write them by hand. But for the no action, it's boring and painful to write them by hand because you don't know all the combinations in which it shouldn't do anything. So instead of writing it by hand, what we can do instead is actually write a program that will write the scenario for us. So what this program does is that it knows the valid values for every context parameter. So if I go back here, so this is a context parameter, this is a context parameter, and these are the valid values. So the program knows the valid value for every context parameter, and it produces all combinations. And in the body of the loop, we know which combination should add an entry, and so on. And this is useful because as we develop, we might find a new parameter in the context. So we don't have to do everything by hand. We just update the script. And so once we have the description of the features, then we have to write the code for the steps. So this is an example of 2 steps. This is a given step, a context step. So it says given a matching server file that exists, it basically creates an empty file with that server path to make the program think that the server file exists. And the opposite, given a matching server file that does not exist, it's just an assertion that the file is not there. So we write the code for all the steps. We run the tests, we see them fail, then we write the functionality, the actual functionality of the code, and we keep doing that until all the tests pass. So okay, this is the output of the tool when you run it. When it's all green, it means it all passes, that's good. And the nice thing about this is that while it's still work in progress, you can see how far you are in the implementation because you have a specific target. You have 4 features, 4 scenarios. So when you start, you have 0 features passed. And you do some work, it's like, so you can quantify the progress of implementation, which is something that's, it's not really easy. It's like when you write a program, you have the functionality in your head, but you have a very vague idea of how far you are. But this way it's very specific, and it's also specific in the application level, not in the implementation sense. So I did the implementation. It took me 1 year because I didn't have time. I was only writing it during holidays and vacation time. So this actually gave me a sense of progress. So it was a way to motivate and to have an idea of how far I am, or how close I'm getting to completion. Just a couple of pointers. So these are tools for writing sort of behavior-driven system tests. I should say that these tests are system tests, so they're not unit tests, which means the test sets up the context in which the program should run. In this case, the context is specific files in the file system. It runs the program, and after the program exits, it checks in the file system to see that it did the necessary changes. In this case, it edited inetd config as expected. So in my case, I'm using a Python framework, and the implementation itself is in Python, the cont'd. But because they are system tests, it could be anything. It could be that the program is implemented in C or whatever. So the fact that these are in Python and Ruby doesn't really matter. And finally, for those that actually do care about dep9 and the replacement of update-inetd, a couple of links, the design document and the actual code repository. Yeah, it's complete. I just need to add a man page and hopefully upload it to experimental one of these days. So I would like to close by saying that Debian and other distributions are full of such legacy things that can be improved. By quoting Zach, beloved DPL, who said that, yeah, the most fun way to contribute to Debian, just find something that needs improvement, take responsibility for it, and just do it. That's it. Thank you. Any questions? Can we have a mic there?
Thank you. The last sentence, and do that, that's nice and all, but I'm trying to do some development on a Debian package, and doing that, that's one, but uploading and really contributing to Debian is two, and all the politics make it very hard. So have you got tips for me to embrace the political Debian stuff and to make life more easy for me to upload changes?
So to upload changes as, so you're not already a maintainer, right?
Yeah, to be honest, I'm not sure even. When you search my package, my name is there, my email address is there.
Okay.
But I don't know how to upload changes. Someone else always does that for me.
Okay, so you're being sponsored by a developer?
Yeah, but I made some new changes, and my sponsor, he isn't answering my emails now. So now what?
We have to find you a new sponsor, no?
Can you?
So Enrico says email Debian mentors, but yeah, you can just grab me as well. That's fine.
Okay.
We can talk about this after the session.
Please, yes.
Yeah. Okay.
Well, thanks.
Thank you. Any other questions? I guess everything was crystal clear. There's a question here.
How is the reception so far of your tool? Is it actually, did you manage to raise an interest? Do you have like people following and asking you to finally upload it?
Good question. So of dep9, what happened is that before announcing it, I actually sent it privately to the key people that would be impacted by the change, and also to the people that were very much against the first incarnation of the proposal. So I gave them the opportunity to give feedback or to object before I would announce it to the world. So all of them basically didn't get back to me, except the maintainer of inetd, Marco Ditri, who was instrumental in refining it and improving it. So, and it wouldn't be at this stage, the design, if it weren't for him. So that was like a year ago. I haven't heard back from him since then. But in the meantime, I've announced a dep. Nobody was screaming loud against it. So that's my understanding of, okay, nobody minds, so I guess it should be okay. And then from some point onwards, well, I've always been receiving bugs that are the main motivation, bug reports for the update-inetd that are the main motivation for the new implementation. And I've always been saying I'm working on a re-implementation. And from a certain point onwards, once dep9 was public, people were starting asking, when is it going to be ready? So I guess that's an implicit sign of acceptance.
Okay, Marco is here. Somewhere, so you may want to
I've heard that he's
later.
here, but I don't know how he looks like. So
I'll try to put you in touch if I see both.
Okay, that's great.
And it's
Thanks.
probably time to be bold, because I went like, oh wow, you're doing that. That's cool. I didn't know about it. So yeah.
Great, thanks. Okay, I guess we're done. There's one more. Give what? In the virtualization, okay, yeah. Okay, that's fine, thank you, thanks again.